Okay, good day everybody, and here's our first lesson, learning our objectives remotely. All right, so I'll explain this the best I can, of course. You can follow along in your textbook. It should be a tremendous help. I'm going to be doing the practice problems that are along the margins in the textbook pages, and simultaneously, there are similar examples right next to it. So example 1 has something worked out for you to read over, perhaps, if you don't understand what I'm trying to convey in our videos here. So this is the way it's going to work, and I will present this the best of my ability. If you don't understand something, you can always contact me, and we can work it out, either hook up on video, online, Zoom, whatever it takes for us to get together for me to explain anything better than what I am on the video. Okay, so this is our chapter 2.2. This is where we're starting. Objective A says to construct a table or a graph from a function rule. All right, so let's see if I'm interpreting this correctly. What we're going to be doing is, here's our table and our graph. Okay, let me maybe like that. That's better. All right, so here's our rule. Construct a table and a graph for this function here of y equals 8x. Okay, and the parameters are for all the values of x that are equal to 0 and equal to 40. So all the numbers of x that are in between 0 and 40. All right, so if I'm drawing a graph for this, or I could fill out the table first for it. This thing here is the table, and what this is saying now, if you remember correctly, when x equals 0 for the function here, that's where I'm going to be plugging in my numbers and get the resulting value for y. So I'm saying here, when x is 0, what is y? Well, if I replace 0 for the x here, I'm going to have that y equals 8 times 0. So when x is 0, y is also 0. And I'll plug it in here. And I'm going to do that for the 10, the 20, the 30, and the 40. All right, so my next one, when x is 10. So that means when y equals 8 times 10, then y will equal 80. So when x is 10, y is going to be 80. Okay? And we'll do that the rest of the way. And let's see if we see any patterns here. When x is 20, y is going to be, well, 8 times 20 is 160. Okay? When x is 30, that's going to mean 30 times 8, which is 240. All right, and plug that in. And the last one, when x is 40, y is going to be 320. Okay, good enough. So let's see. Now I'm going to plot these points on the graph, and that'll give me my line that I need. All right, so the first thing I want to do, this is a personal problem. I'm going to take this and maybe give myself a smaller lead head. And I'm going to plot these points. So 0, 0 is here. What else have I got? I got 10, 80. So 10 for the x, 80 for the y. So I'm going to go over to 10x and go up to 80 for the y. And I'm going to guess it's about there. Okay. I've got 2 points now. I could connect those 2 points and I'd have my graph. I wouldn't have to go through this individually. That's a little shortcut. I'll tell you more about it as we go. The next ordered pair is 20, 160. X and Y. So I got 20, and I got to go up to 160, which might be about here. We're just guesstimating approximately where that point is. So that would be 160. 20, 160. 30, 240. Here's 30, and 240 is almost halfway. So again, I'm just guesstimating. And lastly is 40, 320. Here's 40, then I'm going to go up to 320. And 320 may be there, the lower part of that. Okay. So that's what I've got. And with that, I could connect my line with that. Let's see if I can do this. Here's a line here. This would be a straight line. What happened here? Let's draw a line here again. Some of these are new to me as well. So that's the graph. I'll go all the way through. When you draw a graph, it should be a very straight line and arrowheads at the end. The line goes through the graph at both ends with arrowheads. And that would be the graph that we're looking for. All right, and that is our first objective, constructing a table or a graph from a function rule. The function rule was the function itself, y equals 8x, and these parameters are involved. Make sure you don't go beyond 40. Don't do any extra work if you don't have to, and don't go below 0 on this table, given these parameters. There's another example, in example 1, for you to follow and figure out and see that you're on the right track. Okay? All right. And these, by the way, are the ordered pairs that are written into the table, but simultaneously I could use these and reference these as my ordered pairs. And ordered pairs, as you remember, come in the form of x, comma, y, and they're in parentheses. All right, that's example 1 and objective 1. All right, let's go on to another. All right, here we are again with objective B in this section, and our objective is to identify the domain and range of a function. All right, so this looks like we're going to use the previous problem's data, because it says in practice problem 2, actually that's practice problem 1, isn't it? Yeah, that's practice problem 1. This one is practice problem 2. That's what this is saying. All right, so I'm okay there. State the domain and range for y equals 8x, where 0 is less than x. 0 is less than and equal to. So let's put those little lines underneath here, because it matters. Right there and right here. So that will take care of that. All right, those are lines underneath it, which means we're using the equal to. All right, state the domain and range for that function rule of y equals 8x, where 0 is less than x is less than 40 for all the x values that can't go beyond 40, just like the previous problem. And the range now is a little bit different because the highest the range will go is up to 380. As you remember, we plotted that. So let's dial back to this. And I'm looking for the domain and range of this function. Now notice here, I mentioned this was our data points here, our ordered pairs that are given throughout that we plotted and drew a line through. So if I rewrote this like 0, 0, 10, 80, 20, 160, 30, 240, and 40, 320. Now they gave us these numbers. in the problem. So when I want to know what the domain is, and remember the domain takes on all the x values, or the x value takes on the domain, there is no way I can get any other numbers other than 10, 20, 30, and 40, and of course 0 up top, because that's what we had to plug in for us constructing a table and graph for y equals 8 times x. So whatever number value you're going to put in there, it's going to spit out a integer. All right, they told us here, they gave us the x values, and they're all integers, multiples of 10, if you will. And the only number that can be the output is another integer. There's no way I can get a decimal number. There's no way I can get a fraction. They're all integers. Okay, so given this idea for the domain and the range, well, I can just look at my values here that I've got. And the domain then, which are all the x values, I could write the domain, I could write it as I'll write it in set builder notation, I guess that's what I'm looking for. The domain is x such that straight line, it means such that, x such that x equals 10, oh, I beg your pardon, 0, comma, 10, 20, 30, and 40. And that would be our domain. You write these from the smallest number to the largest. Consequently, the range, which are the y values, are going to take on y such that y is going to equal, and I'll look at my list of numbers that are on the y-axis, or related to the y value. So y will equal 0, comma, 80, comma, 160, comma, 240, comma, and 320. And this is the domain and range of this function of y equals 8x. Okay, and that's the idea. Okay, so let's see, another general rule here to tell you about now. I'll speak to you now about it. And that is, if I have I'll do 5 ordered pairs, okay? I'm going to say 2, comma, 5, 3, comma, 6, 4, comma, 7, and 5, comma, 8, just as an example. So now when I'm looking at this as is this a function, as long as the x values are all different numbers, then this is going to be a function. And the domain, therefore, will be d for domain equals x such that x equals 2, 3, 4, 5. Okay, it is a function, so that would be the domain. The range then, accordingly, would be all the y values. Here, 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 and here, which is simply y such that y equals 5, 6, 7, 8. Okay, that's another example of what we did with the original practice problem, but now I want to make one change with you. All right, I'm going to take this, one of these x values, and I'll say the 5. I'm going to change that. I'm going to erase it and put back in a 2. Okay, I'm going to put a 2 there instead. Now when I look at these values for the domain, I've got 2, 3, 4, and 2. Oh, I have 2 2's here in my x values. Oops. Here's a 2 here and a 2 here. So therefore, this is not a function. Not a function. Because it has 2 values of the same in the x format. You can have 2 of the same y's, but not two of the same x's. Okay, when this comes up again, which I think it will be, I will elaborate on that a little bit more. Okay, so that was practice problem 2. And let's go ahead and go on. Okay, here is another example using objective B. And that objective was what? To identify the domain and range of a function. All right, so this is another example of it. And determine the domain and range for the following relations. All right, so we could say the domain then here is going to be all the x values. And I'm looking to make sure I don't have 2 of the same number. So this is a 3, this is a 1, this is a 0, and this is a letter A. Okay, none of those are the same, so I'm going to have a function with the domain of 3, 1, 0, and A. That's going to be my domain. And if they say write it in set builder notation, it's going to be D such that D equals 3, 1, 0, A. The only difference in writing set builder notation or just writing it out. Okay, the range then is going to be, remember we can have the same number for the range, and that's going to be all the y values. So I got a 3, a -1, a -3, and a b. They're all different, but I could have the same value for the range. All right, but this is going to be 3, -1, -3, and then your b. Okay. Domain and range. That's your example for that. Okay, another rule that they have, another example that they're given. If I had a graph. All right, let's go back up to our original. This is a graph here. And the only difference they've got in our example on page 165 is that this line is gone. Well, let's see here. I take that back. Let's see here, domain. I'll take the values that we're dealing with. Let me try that. Okay, on page 165, practice problem 3B, they're showing you a graph similar to what I've got, and they want us to write the domain and the range. Okay, so because this graph are just points on it, because this graph is just points on it, that means I'm going to have some ordered pairs that go with these numbers. So if I look at this bottom one here, the ordered pair for that is -2, -2. This dot here is -1, -1. This dot with a 0 is just simply 0, 0. What else have I got? 1, 1. And the last one there is 2, 2. And they want to know what is the domain. The domain is going to be all my x values here. There are none of the same, so it's going to be -2, -1, 0, 1, and 2. Okay. So that's the domain, and the range is going to be all my y values. -2, -1, 0, 1, 2. Okay, now you could list, I want to clarify myself here as I'm speaking. As I'm listing the domain, if I happen to come across a domain where I have the same x values, well, that's still the domain. However, it's not a function when I have two of the same x values. That's the difference between the two. All right, I want to clarify that to make sure that's understood. You could still write the domain and have the same number for the domain, but you would just, if you had two of the same number, you're just going to write down that one number one time. You wouldn't list it twice. Okay, but having two of the same x values really means that it's not a function, which is a different conversation slightly. All right, I just want to clarify that. Let's go on to C, where I have an input and output. And I'll write that down without you waiting for me to write it. Hold on. Okay, here is part C, where I have an input and an output. All right, and I want to find the domain. All right, so quite simply, the domain is going to equal, inputs are your x values. Whatever you input, you're going to get a resulting output, which is going to be y, if we have our independent variable of being in the function. So it may be like we had before, y equals 8x perhaps. Okay, or 8x plus 1, something along that line. So for every input, I'm going to get a resulting output in that case. I could figure out the function now, but I don't want to do that right now. I just want to know what is the domain. And as long as we understand that the input are your independent variables, that really is your x values. So when I write my x values, the input numbers, I want to put them in numerical order, from smallest to largest, ascending order. All right, so that means what's the smallest number? It's -2. And then 3. How about a 5? Then a 7. So that's your domain going left to right. Your range now has got to be paired up with the first number. The first number in the domain is -2, so the first number listed for our range is going to be 0. 0 goes with the -2. It's just the order that we're listing them as. So then I have 0, 1 would go with the 3, and 2 then would be next, and that would go with the 3. And we do have a 0 now, don't we? Yes, 0, 1, 2, 4. 0, 1, 2. Now we're going to skip 3 and go to 4. Okay, these are our pairings. So this is saying for the domain, when x is -2, y would be 0. When x is 3, y is going to be 1. And they're just our ordered pairs. I could write it up this way, is -2, 0. What have I got here? 3, 1, 2, 5, and 4, 7. Then you can see it a little bit easier that the numbers are paired up, going from smallest to largest. Okay, not a real popular one there. We usually get the domain and range from maybe the graph with the points on it, or these sets of like the first part, A here, are set of ordered pairs. I do anyway. I ask, what is the domain given these numbers here? And what's the range? Okay. That looks pretty good. I did have A here for the domain. Yes. B in the bottom one. Yep, there's the B. Just making sure I didn't forget something. All right, so that is example 3. All right, here we are with a story problem, our favorites, but bear with me. Boy, I wish we were in class to do this, but Let's break this apart and you will see it's not that difficult, especially using a calculator. Kendra tosses a softball into the air with an underhand motion. The distance of the ball above her hand is given by the function h for height equals 32t, and t is for time, minus 16t raised to the second power. That's what that caret 2 means. And it's in between the interval of 0 less than or equal to, for 0 is less than or equal to t, which is less than or equal to 2. So in between that 2-second intervals, where h is the height of the ball in feet and t is the time in seconds. And it says to construct a table that gives the height of the ball at quarter-second intervals starting with 0. So we've got us a fun problem to do. So let's see here. I want to construct a table. Here's a table, and this would be t, and this would be h. T is for time, and they want it in quarter-second intervals between 0 seconds and 2 seconds. So let's see. So when t equals 0, what is h going to be? When t equals 1/4, what will h be? When t equals 1/2, what will what will h be? Next will be 3/4, all quarter-second intervals. What will h be? How about after 1 second? Looks like I got to keep going here till I get to 2. So then I'm going to have 1 1/4. Let's see, 1 1/4, 1 1/4 for now, which is 5/4. I'll use that when I'm doing my math. And then how about another one, which would be 1 1/2? Well, that could be 1.5. And then 1.75, or 1 3/4. And finally 2. So we've got to get facts, the height based on these quarter-second intervals. Now, use your calculator, of course, if you want. That's not a problem. And you're going to plug it into this. I'll write it up here. 32. This equation: 32t minus 16t squared. All right. Wow. All right. So let's try this. When t is 0. Then h is going to be 0. The height will be 0. You put in a 0 for t here, and it just end up with 0. Next, I'm going to have 32 times 1/4 minus 16 times 1/4 squared. Okay, so this will end up being 8 minus, this is 1 over 1/4 squared would be 1 over 16. So that's going to be 8 minus 1, which equals 7. Okay, so you can see we've got some work to do here. Next interval would be 1/2. So let's try that. 32 times 1/2 minus 16 times 1/2 squared. Okay, 32 times 1/2, that'll give you 16, minus, let's see, 1/2 squared is 1/4. Notice our order of operations says to do parentheses and exponents first, and then you're multiplying it by negative 16. So here, this is going to be 1/4 times 16, negative 16. So what is that, minus 4? 16 minus 4 equals 12. And then we go ahead again to 32 times, what's the next? 3/4. 3/4 minus 16 times 3/4 squared. Okay, so that looks like it'll give us 24 minus, and what's this one going to be? I got to square this first, so that's going to be 9/16. And that's going to be, well, negative 16 times 9/16. Okay, what happens? Negative 16/16, that gives you negative 1 times 9, which is minus 9. 24 minus 9. -9 is 15. Okay, good enough. Let's make some room here for the 1. And how about it? Let's change our color. So this is 1. So this is just going to be 32 times 1 minus 16 times 1 squared. Well, that'll be a little easier. It's 32 minus 16, which is 16. Okay, then we've got 1 1/4. Now I don't want to use 1 1/4. I want to change that to an improper fraction. So that equals 5/4. This one's 3/2. 1 1/2 is 3/2. All right, so let's try it. I got 32 times 5/4 minus 16 times 5/4 squared. What do I get? 4 goes into 32, 8. 8 times 5 is 40. Minus, let's see, 25/16. Let me do it here. 25/16. That's 5/4 squared times this times 16. I got my minus sign there. Times 16. 16's cancel, and I got 25. 40 minus 25. 15. Let's circle these numbers here for now. Okay. And erase this. And now I'm moving on to 3/2. 3/2. So I got 32 times 3/2 minus 16 times 3/2 squared. Oh, what do I got here? 2 goes into 32, 16. 16 times 3 is 48. 48 minus, let's see, this becomes 9/4, that 3/2. So when I do the math on this, it's going to be 4 goes into 16 4 times, and 4 times 9 is 36. 48 minus 36 looks like it's 12. One and 3/4. 1 and 3/4 changes to be 7/4. And that's what I'm going to use for this guy here. So I've got, erase this. 32 times 7/4 minus 16 times 7/4 squared. All right, first one, I've got 4 into 32 is 8. 8 times 7 is 56. Minus, I've got to square this 7 4, so it's going to give me 49 over 16. And again, times this 16, really, so it makes the math easier to do. These 16s cancel, and I'm left with the 49. So it's 56 minus 49, which equals 7. Okay. And one more to go, which is the 2. So that'll be 32 times 2 minus 16 times 2 squared. 32 times 2 is 64. And then I'm going to subtract 2 squared, which is 4. And 4 times 16 is 64. 64 minus 64 is 0. So these are all our values now. I could plot these points if I wanted. Let's see here if I do this. Okay, and here is our graph of this function taken from our table of values here. I could have listed them here, actually. 0, then the 12 would go here, 15, 16. No. 0, I forgot the 7. Let's see if I can do that right. All right, so it's going to go and look like this. 0, 0, 1/4 is 7, then 12, then 15, then 16, 15 again, coming down the other side. After you toss the ball, it makes that arc. 12, 7, and then back to 0 after 2 seconds. And that's what this, if we interpret that, after 1/4 of a second, the ball is 7 feet above the ground. After 1 second, it's 16 feet above the ground. And we can look at it here on the graph to determine that. So this is the arc of the ball. Think about pitching a softball. It usually has that motion of an arc or a picture of an arc. And we can see after 2 seconds, the arc is completed and the ball is back to 0, the ground. This is a function. If I look at this as ordered pairs, which I started to do up here, these are all ordered pairs, right? And none of the x values repeat. I don't see another of the same number, so that tells you that this is a function. And then you could also do what's called the vertical line test. I could draw a line, if this is an arc, I can draw a vertical line anywhere, and that line will hit the graph of the equation in only one place. It cannot hit the graph in 2 places. So that means this is a function as well. We already determined it from using the ordered pairs that it's a function, but now we can use the visual and draw a vertical line. If I have a graph kind of like this, if this is my graph, and then I've got a graph that's going here and here and here and swoops around like this, then at this point here, it fails the vertical line test because it's hitting it more than one spot. Up to here, it may be considered a vertical line, passing the vertical line test. But when you get maybe an S shape, it's not a vertical line test. Or it's a vertical line test, but it would fail the vertical line test. Okay, enough of that. Okay, in this example, I'm going to sketch the graph of x equals y squared. All right, in order to do that, I need to get some relations or ordered pairs. So for this, if I've got x equals y squared, I'm going to draw a little t-chart here. And let's say I get about, I don't know. Then the book, they're going skip counting by some. I guess I can do the same thing. And say 0, here's my x values, and this will be my y value. So when x is 0, x is 1, 1, 4, 4, 5, 5. How about I do that? All right, so when x is 0, y is 0. When x is 1, y is 1. But I got 2 1s. So in this case here, if x is 1, 1 equals y squared. And if I take the square root of both sides, I've got that y equals plus or minus 1. So here I've got a positive 1, and this would be negative 1. Okay, let's do that for 4. If x is 4, that would be 4 equals y squared. And again, I'm taking the square root of both sides, so y is going to equal plus or minus 2. So here I've got a 4, so that would be 2, and this would be negative 2. And finally, I got 5 here. Let's see how that works out. 5 equals y squared. X is 5. I take the square root of that. Then y is going to equal plus or minus the square root of 5. And this would be positive square root of 5, negative square root of 5. All right, well, using the table, I can see that it's not a function because I have 2 of the same numbers for x going to different y values. So that tells you something there. If I were to graph this, let's see if I can graph this. I'm going to have, let's try and graph these. So I got 0, 0, which is here, 1, 1, 1, negative 1, 4, 2, and 4, negative 2. And then 5 square root of 5, which would be a little over 2, maybe here. When I run into this situation, as well as you will, you just approximate where it is. And when x, where am I here? When x is 5, y is going to be the square root of 5. And then I have that and negative. Same thing. So you can see when I fill in this graph and attach the dots, I can also see that this is not a function because it fails. It fails the vertical line test. The line hits the graph in 2 different places. It can only hit it in one for it to be a one-to-one relation and therefore a function. Okay, and that's all there is to that one. And the last part in objective D is about the vertical line test. So I feel I have gone over that enough. And you may want to look over example 6 on page 168 and just verify your knowledge that you understand the vertical line test and how you determine if a relation is a function by the vertical line test. Very easy to do too. All right, that's our first lesson, 2.2, and we'll move on from there. Have a good day.